Good afternoon, sir.
Hello, Anna. Is it audible to you?
Yes, sir. Yes, I can hear you, sir.
Okay, so in the last class, I covered the half of the complex numbers along with some of the properties of that.
Yes, sir.
So did you went through the NCRT examples and problems?
No, sir. Yesterday I had an exam, sir. I couldn't do that.
Okay, no problem. So I'll just cover the rest of the part and then you can just go through the rest of the part by yourself. Okay? From
Yes.
the NCRT examples and the problems.
Okay, sir.
So I'm just sharing my screen. Let me know if it is visible to you or not. Shared and
Yes, sir. It's visible.
all right. So we have discussed nine properties that day, the last time when we were discussing,
Yes, sir.
and today we'll be moving to the some other properties. Okay. So the first one comes out to be summation property, which is you'll be having two complex numbers, okay, and the summation square. Okay. I already told you that summation and whatever we are discussing, the individual comparison doesn't matter, right? I can't compare it with some other things. At least
Yes,
for greater than or less than. For equals to, we can say, okay, if the real part of this and this are equal and imaginary are equal, then we can say they are equal. Apart from this, if both things are unequal, we can't say whether which one is greater or less. For that, we have a parameter called the modulus of two. So whatever we will be discussing, it will be based on the uh, whatever we have written here. Like this. So
yes,
what
sir.
is this? It should be. It is actually equals to z1 square plus z2 square plus 2 times of real of, we have to go with the real part, z1 z2. So this is what the solution will look like. Okay, if you see, like, it's up to you whatever you want to take. You can take here as z2 also and z1 also. It won't make any difference to your final solution.
Yes, sir.
Okay, this is one property, and the another property is z1 plus z minus 2 is less than equals to z1 plus z2 indivisible. Okay, this will always be greater than equals to. From where we get this property? This property comes up from the I can say triangles law of law of inequality. Okay, if you want to prove this thing, you have to go with the previous method. I'll say check some properties I must have mentioned in this part. Yeah, this one. Okay, you have to if you want to expand this part, no? The second 10th property, expand in this way. For example, if you see carefully, just replace this thing with this. So z1 plus z2 square, what it will be, will nothing but z1 plus minus z2 and the z1 plus minus z2 this. Okay, now one more thing you have to be careful. This is for the plus minus, right? So let's say you are checking for the this property z1 plus z2 square. So in that case, how you have to proceed? Z1 plus z2 and z1 plus z2 of this. And you also know this property. What is it? Right? We
Yeah.
can We
Yes, sir.
can just distribute that.
Yes, sir.
So you'll be getting Z1 plus Z2. It got distributed. Okay. Now you can see this part, this part. What you are going to get? Z1, Z plus Z2, Z plus I think Z1, Z2 plus Z2, Z1. This is what we are going to get. So you know this is nothing but Z1 square. This comes out nothing but Z2 square. The rest part is this portion. Okay, we just have to solve this one. If you can see this part carefully, we just have to solve this one.
Yes, sir.
Okay, so yeah, that's all for the answer here comes out to be. Any doubt?
No, sir. Got it, sir.
Okay, and for this one, what you can do is you can just apply the same method. Okay, and here I'll say mm, what you can do. Okay, okay. For this, I'll say we have to go with some different method to choose this inequality part. Okay,
Yes,
and do you
sir.
want derivation for this one also?
Sir, I think I understood why, sir. Like,
Okay, look, if you want what I'm saying, if you want an explanation, you can just let me know because we are similar to this. Four properties are there. Okay,
yes, sir.
whatever you have to do, you just have to go the whatever properties we have studied for the smaller portion. We just have to apply all those in this bigger identities. Okay, you
Yes,
will get your answer. Okay, I'm removing this because we just have to mention properties here, not the whole derivation part. Let me just remove. Can just okay, leave it. Fine. Now, the next we have is the 11th property, the 12th we are discussing. That is 12th property. So, what does the 12th property say? It's the same thing. Whatever we have discussed here, Z1 minus Z2 will always be greater than this thing. Okay,
yes, sir.
this is the final. And look, one thing is this modulus will always come up as positive, but if you see by chance this comes out to be 6, this comes out to be 7, so this will come out to be negative. So it's just an unfair comparison. So we put overall one more modulus. So the whatever the answer I'm going to get result from here, let's say 6, 7 minus 1 due to this modulus comes out to be 1. Okay.
Yes, sir.
Okay. I'll just give you a hint how this property can work. Okay, this one and this one. For example, just assume you have Z1 written as 2 plus 3i, okay, and Z2 written as how much? 4 plus okay, let's make it as minus 8. So if you see, if I calculate Z1 plus Z2, what I'm going to get? My answer will come out to be, so when I add this will get cancelled, I'll have this one, so my
Yes,
answer will be 16. If you take individual, this will result me something around 2 and 3. The modulus of it will be 4 and 9, something around 13. And this part will result me somewhere around 16, and what is this, 3 and 9, so 25. What I have got 20, this and this. Now you know under root is there, okay, and under root of this 5, so this is 6. It should always be less than or equals to 5 plus under root 13. You know this 13 is I don't have an exact value, but you know if instead of here 3 would have been there, 3 5 plus 3, it is greater than equals to this, is it?
yes, sir.
And I know 13 is greater than 3. Actually, it will be somewhere around 3.5 something. Okay,
Yes, sir.
because for root 3 square it comes out 9, and
9. Yes,
4 square comes out 16, and 13 lies in between this. So I can say the under root of this will in between somewhere here. Okay?
yes, sir.
Yeah, this is one proof for the identity I have just given. And same we can do for vice versa. For example, okay, let's reverse it. What I want to do, I want to reverse it. This subtracted from this to this. What you are going to get? This will get added up. This will be 2, and this will be somewhere around 6. 4 plus, what is this? 36. Under root will come out how much? 40. Let's check individual. This is how much? Under 13. We already calculated. This is how much? 5. Okay.
5.
When you do subtraction of it, what you are going to get? I just told you like it will be somewhere around 3.5. So if you see what I am going to get, 1.5. Right? How
Yes,
much
sir.
difference? It's very high difference. Okay.
Yes, sir.
Okay. If you see which case will result to the equal answer.
If they both are equal, like Z1 is
Uh,
equal to.
yeah, actually, it will be Z1 equals to Z2. Basically, in that case, can you say it is equal, or yeah, ideally that will be the only thing. Okay.
Yes, sir.
So I'm just removing this to the part. Okay. Mod and mod is important. Don't forget to put mod. Now the same what we have to do. I'll just include 13 over here. This is something around A1 Z1 minus A2 Z2. Okay.
Yes,
And
sir.
you call it as, instead of A2, let's make B and C. Square plus what it is? B of Z1 plus A of Z2 square. It will come out to be A square plus B square, and the rest is Z1 square plus Z2 square. This is one property. Somehow it will get common from our situation, whatever we are expecting from this. Okay, if you want derivation, again, you know the same method we have to go. What? Make it like this: A1 Z1 minus Z2, and another is A1 Z1 minus B Z2, and you know this I have to put, so it will get tested with this, or that's tested with this part. So you can see you're getting a square of it. Somehow it will come out, so it will become A and A square. Is it?
Yes, sir.
Same you will get from here also. A square for Z2. Okay, and here you have got A2 and this Z1 square. So you can see, if you take common out, what you are going to get? Z1
Z1
plus
plus
Z2
Z.
square. Same you are going to get for the B2 also. So for B2 you will get common this one, Z1 plus Z2 square. Okay, and if you take Z1 Z2 square, you will have this plus this Z1 plus Z2 square. Is that clear?
Yes, sir.
Okay, and okay, if you see, I have taken very okay. Now one more thing will come out. I took this and this and this and this, right? Apart from this, there will be one pair of this also. So you will be having A, B, Z2, and from this you will be having A, B, Z1. Same I'll be having from this side also. What is that? A, B, Z2. But if you see this side, I have negative. That side, I'll be having a positive. Okay, get cancelled. At the same time, it is negative, so I'll be having a positive A, B, Z1. Okay, it
Yes,
cancels.
sir.
You can see these different pairs get cancelled out. The Z1 and Z1 pairs will get added up. Okay, so it will result in this kind of relation.
Yes, sir.
So the best condition for this is, you have to just keep remember that one should be negative, another should be positive, and the coefficient should be switched in the second case. For example, here coefficient is 1, here is b, and here b, here 1. Okay, the coefficient should be switched out. You can okay, the special case of it will be z1 minus z2 plus z1 plus z2, square outside. It will result for, what will be the answer? 2 times of z1 square plus z2 square, right?
Yes, sir.
What I have done here, I just put the value of a and b equals to 1. Clear?
Yes,
So
sir.
this is just in special case, so I'm not writing it as another property. This is just a part of it. So the rest of we have is fourth property, which is based on the okay, amplitude or something. Okay, so this will result you something around, what I can say. Okay, z1 dot z2. What you are going to get out of this? You can just do a separate of it. Z1 plus I think it should be Z2. These are some of the extra properties you have to be careful.
Yes, sir.
Okay, any doubt till here?
Can you explain the 14th one?
14th one, 14th with what?
So, like, can you explain what exactly amplitude like?
Okay, no, actually this is argument. Okay, sometimes we write it as arg. Okay,
Okay.
sometimes we write it as this. Okay, so both are the same thing actually. We can
Okay.
call it as amplitude. We can call it as argument. So that's the property it is. Yeah.
Okay, sir.
So that's the thing. Okay.
Yes, sir. It's clear till here, sir.
What happened?
It's clear till here, sir.
It's clear, right? Okay, let's move to the next rest of the part. Okay, so yeah, one more thing. It should be plus 2k pi. Okay, 2k pi basically suggests you to go adding 360 into some n value. For example, it can be 1, it can be 2 and something. Okay,
Yes, sir.
so this is what we are just adding into the angle. So I can say my k should be belong to integral value. It should also always belong to integral value. The significance of this part you will understand when you will be solving lots of problem based on this.
Yes, sir.
The rest is we have next property is 15th. What it is again the same. The argument or amplitude whatever. Let's say we have okay. So y naught by y1 okay is equals to how much? I can say okay. Let's not write this property. I have not taught you this part because so I will prefer not to explain this one for now. Another property, what can be? Okay, 15, the last property I'll say. One property, I'm missing something. Okay, okay, the power of z. Okay, what it should look like, it will be whatever it is, n times amplitude of z, okay, plus 2 times of q. This is one more thing. Yeah. Okay. So this is the final properties we are getting all things. Where this k should belongs to 1. These are all properties of your complex number. If you have any doubt till here, so let me know, or we can just move to the next.
Sir, K belongs to I, sir, integer.
Yeah, integral value. So it can go from like anything. Yeah, it should be I actually. So it can go from minus infinity to infinity, okay? Like minus 2, minus 3, 1, 2, 3, whatever it is.
Yes, sir.
Okay, so that's the thing. Any doubt till here?
No, sir, clear, sir.
Okay. Okay, what is the value of I? I think I didn't told you till now.
Square root minus 1.
Minus 1. It is under root of minus 1. We are discussing about. Alright, so next is De Moivre's theorem. De Moivre's theorem. What it does say is that actually it's a very simple statement. If you see, we have discussed something like okay, it's basically it says that if you have written something like cos and theta plus what it is I times of sine and theta n times of theta, so you can read it the same thing as cos theta plus I times of sine theta power n. Clear?
Yes, sir.
Okay.
Is it
Um,
derivation for this or?
okay, I'll just go with this part. If you could remember, I told you the Euler's form, right?
Yes, sir.
What is that? I told you if some complex number it is written, for example, r the magnitude, cos, let's say theta is there, okay, the angle. I'm saying the angle is how much? N theta plus sine of I side n times of theta. I told you we can represent whatever it is in the form of e to the power I and whatever the angle is. So here you can see the angle is n theta, is it?
N theta. Yes.
I can rewrite the same thing as I theta to the power n. Now again, can I write this thing as e? Now you know e to the power I theta can also be written as cos of theta I cos theta plus sine theta I should be there, and the rest power is there. Understood?
Yes, sir. Yes, sir.
Same bit. And I think you will get the explanation of this theorem by this also. You can see amplitude of z to power n. Mean to say, yeah. So this is the thing, amplitude of z to power n. So this will be getting right. Amplitude of z. If z, I am saying z to power n. Let's say z was something cos of theta plus I sine of theta. So when I'm doing z to power n, so I'll be getting this also this side, right? So
Yes,
what
sir.
what my amplitude becomes? Whatever the power of it will give you, but you know the power of it can resolve into cos of n theta plus sine of n theta. And what is amplitude? Amplitude is nothing but n times of theta. N is a constant value, so it will come out outside, so n become amplitude of theta. Understood? So
Yes, sir.
amplitude of a normal z, amplitude of this is nothing but amplitude of normal z. So I think this gives you the explanation of your previous theorem also. Alright, so let me just remove this. So this is all about the short of De Moivre's theorem. Okay. Now let's go back and study cube root of unity. Cube root of unity. And this is the important thing basically. If I ask you, solve this thing, can you solve this one? What should be the value of x?
1, sir.
1. Okay. Is it, will it be 1 only or anything else?
It will be 1 only, sir.
Okay, let's see. Can you see I can rewrite this thing as x cube minus 1 equals to 0.
Yeah, yes, sir.
Okay, and this can be rewritten as x minus 1 x square plus x plus 1. Basically this is property of x square minus okay, a square minus b square can be written as a minus b. Okay, a square plus I think it should be b square plus ab. Okay, this is what we can write it.
Okay,
Okay,
yes, sir. So it's a cube minus b cube, right?
yeah, it's a, yeah, it's a cube minus b cube. Sorry, it's a cube minus b cube. Okay, so we can write this in this format. So this is what I have written, and you know whole thing is nothing but equals to 0. So it means x minus 1 is equals to 0. So this is a real value of x which is visible to you, but there's one more value of x. What it is? This one. Can we solve this thing? Let's see. You know quadratic method.
Yes, sir.
X equals to minus b plus minus under root b square minus 4ac divided by 2a times. So I'll be using directly that. So here minus 1 plus minus under root, okay, b square, that is 1 square minus 4 times of ac minus under root this divided by 2 times of a. So this is one more, two more values are there. So if I just read, you can see it as minus 3. This negative 3 can be written as under root of minus 1 into 3. So, and minus 1 is nothing but I times of under root 3. Makes sense? So you can see you have got two more properties, 1 plus minus I under root 3 divided by 2. You can see why we can see only this x equals to I, because that is a real value, right?
Yes, sir.
The rest of the two values are hidden ones, and we can call these as imaginary. You can see I is there, so it's 100% sure that it's an imaginary values. In grade 10th, what we used to say that if my d determinant goes lesser than 1, lesser than 0, so we like there's no possible of the real roots, right?
Yes, sir.
but there is a possibility of imaginary roots. So here the result comes out to be imaginary roots. Any doubt here?
No, sir. Clear, sir.
Fine. So these are imaginary roots. Okay. So that's the thing. Now, if you see, if I ask you what is the cube root of unity, cube roots of unity. So what will be? It will be 1. It will be minus 1 plus under root minus by 2 minus 1 minus I root 3 by 2. So if you see, whatever the highest power is, that many roots will be available. Now if I ask you how many will be real, how many will be imaginary. So it is very simple idea. Whatever number of real roots you can figure out, that will be real, and the rest like you can do n minus real root will result you the imaginary ones. Is that clear?
Yes, sir.
Okay, when we say that we have some equation, let's say that is of order n, and we say only two roots exist, what about the rest of n minus 2 comes out as an imaginary root? Okay, that's why we are not able to get that.
Yes, sir.
Okay, so this is the case. All right, so we can, if you see, can I write this thing as omega cube equals to 1? Basically, I'll be getting the value of omega here.
Yes, sir.
Okay, so here if I ask you what are the values, so I can say omega is one of the, okay, yeah, omega is one of the cube root, one of the imaginary cube root of unity. Okay, so um, this thing can be written as 1 plus omega square equals to 0. We can
Yes.
write, right? Okay, so here what happens, omega is one of the imaginary root. Okay, basically if you see, we have that equation. Okay, but we have one more representation for these, like you can say this is 1, you can call it as omega, you can call this as omega square. Okay,
Yes, sir.
it's up to you. If you say this is omega square, you can call this as omega. All right, so that's the thing. Any doubt?
No, sir. Clear, sir.
You can, like, we can also do the final check. Whatever you want to take as omega, let's say I'm taking this as omega, so this is I root by 2 by 2 plus I'm taking this as omega square, so minus 1 by 2 minus 1 root 3 by 2, cancel, minus half becomes 1, get cancelled, comes out 0. Clear?
Yes, sir.
Okay, that's the thing. Even if you do something like, if you take this as omega minus 1 plus I under root 3 square, if you are saying this is omega, if you do square of this thing into say, if you do square of this thing, you will result this. If you do square of this thing, you will result this. Okay,
Yes, sir.
so all the things actually hold correct. It's not the case that if you put the value, you will be getting the wrong answer.
Yes, sir.
So we can say the root. See, मेरा phone उठा ले. Yeah, for x cube equals to 1, what are the possible roots I can say? That will be 1 omega omega square. Is it?
Yes, sir.
All right. So this is all about the imaginary root. Okay. Now I'll discuss the polar form of cube root of infinity. Cube root of unity. Okay. So what is the polar form? If you see cube
Sir,
root of unity, what what happened?
writing in terms of cause and sign.
Yeah, exactly. The writing in terms of cause and sign. Okay. So how I can write one in the terms of cause and sign? We can see I have to write x cube equals to 1, but in this in the form of cos and sine. Okay, so cos 0 plus I times of sine theta. Sine 0, will it make sense? Because this will result 0 and this whole thing will result 0.
Yes, sir.
Can we do this?
Yes, sir.
Okay, so here if I ask you what is the value of this theta, this angle 0, so what are the possible ways?
Um, that can be pi by 2 or
Pi by 2 and this. Okay, so look, we don't have to go in this way. You know x cube have how many roots? Just let me write in the form of roots. Okay, we will be writing the values of the roots in the polar form. Okay, so let me remove it again here. What was the x cube equals to 1? You know what are the roots?
so yes, sir. It's
Belongs
minus
to 1 omega square, right? And you know 1 can be written as cos 0 plus I times of sine 0. This omega was, what was the value of omega? You can say minus 1 plus anything you want to take, I times of 2. So can I say I can rewrite the same thing as minus 1 by 2 can be written in the form of cos of some theta plus I times of what is this minus root 3 by 2. It can be written as in some sine form of theta. Any possibilities there?
yes, sir.
Okay, so any theta which have cos as minus 1 by 2 and sine as root 3 by 2. So I'll just take a graph
60 degrees.
for a wait. I'll just get a graph. So this is what your sine looks like, and this is what your cos curve looks like. Maybe yeah, it's the same. Something. Okay. I want cos is negative. So cos is negative in some this region, and this is positive. So in this region, something around. Okay.
Yes, sir.
So what I am going to get? um, if I get like in front of 60, because this value I'm going to get at 60, in front of this is 120, right? So I can say if theta is 120 degree, I'll get cos this thing as minus 1 by 2 and this thing as root 3 by 2. Okay,
Yes, sir.
so let's remove it. Sine of 0 degree was there. For omega, what I can write? Cos of 120 degree. It can be written as 2 pi by 3. Okay, so it
Yes,
is 2 pi by 3 plus I times what is it? Sine 2 pi. Okay. The next is this one. Here, what happens if I said if I took this as positive, this part is negative, like 1 by 2 and plus root 3 by 2. Okay. And in the next omega square, I have to take in omega square, I have to take this as minus 1 by 3 by 2. So where I will reach? I will reach somewhere where both things are negative. This somewhere around this region. You can see both things are negative here.
yes, sir.
So okay, I can multiply it with the 2, I'll reach here directly. So if it is 2 pi by 3, the answer will be here will be 4 pi by 3. Is it clear?
Yes, sir.
So that's the thing. Cos 4 pi by 3 plus I times of sine 4 pi by 3. Okay. And this will result for this part, and here plus this part. So you can see we have written this whatever answer we had in the form of this cube root of what is it in the polar form. I
Yes,
hope all things should be clear till now.
yes, sir. Clear.
So, okay, what one more thing? If you plot all these three cube roots of infinity on an arcane plane, what you are going to get? You will be getting a vertices of equilateral triangle. Okay.
Yes, sir.
The reason behind them is okay. Wait, let me see. Okay, if I ask you what are the angle between each of them, you can see for this I was at 0 degree. For this I went as 120 degree, and for this I told you multiplied with 2, and it means 240 degrees. Is it?
Yes, sir.
If I plot them on a single way, you can see. Let's say this is my argon plane, okay, and I am saying here I have one. What I have to do, I'll go at 120 degree something here, and I will get at 1 meter this point. Is it? And from here I'll go one more point and I will get this. And if you see from the center point, let's say the origin, this one has the same amplitude as one, because amplitude will remain same, right, in
Yes, sir.
each cases. So this is one, this is one, this is one. So that's why you are getting equilateral triangle. This, that's why these are working as a vertices of equilateral triangle. Okay.
Yes, sir.
All right. So let me remove it. Although it was simple enough, like if I just make it on argon plane, you can see this will lie on a, this will lie on a x side of axis, basically on the real axis. Okay, imaginary, yeah, real negative, and imaginary negative. Okay, so you can see this is 0, this is 1. So somewhere around from here you will be having value here. Okay, now from here you have to go at some 120 degree to get this should be negative, mean to say here this side somewhere, and this should be positive. So which reason is there? So this kind of thing.
The second quadrant?
Yes, second quadrant is actually clear, but no, it should not be second quadrant, because I need to maintain what I can s- I need to maintain a angle of 120 degree. Okay, then I'm only going to get it. So okay, this is I portion. It can be negative. That's fine. I was just missing this part. And you can see this portion is negative in both cases. Okay, so what we can do, you can just go from here at 120 degree, let's somewhere here, and in the opposite side also. If you go this side and get at one, let's say this is one, this is 1 meter. So which point it will represent, you can see imaginary part is positive, mean to say ampere. Okay, this coordinate is mentioned here, mean to say I can say this is omega, and this is omega square. Clear?
Yes, sir.
So what my final result is, apart from this, if you have something like omega to the power, like say x to the power n, so what will happen, you will be having roots as whatever you get 1 omega. Okay, not this actually. If you have this as 1, okay, so what will be the root? It will be x to the power 1 omega, omega square, till where omega n to power minus 1. Is that clear?
Yes, sir.
Now you see, you have to divide whatever the 360 is, you just have to divide that into this n. So whatever the angle you are going, that will be the equally distributed angle will be there. Okay, if you plot those into argon plane, one will be here, and after that, whatever the angle theta will be getting, theta another. In this format, you will be having whole thing. Is that clear?
Yes, sir.
Okay, why I have taken angle theta? I'll just give you the example of the previous one. You can see I had x to the power 3 right here, and was 3. Total angle is 360, and when I did this 3, basically I got 120. You can see for each of them the difference, like angle in the difference was 120 degrees. Is it?
Yes, sir.
So let's remove. Now can you see one more thing, that if, just a second. Okay, so I hope you have got the basic idea about the angle and all. Although if the syllabus is just about the basic things, so this will not be in your upcoming exams and all. Okay,
Yes, sir.
this will not be a part of your exam. Just right. Theta will be um, 2 times of k of whatever it is, 2 pi by n. Okay, actually it will not be like this, it should be okay, what I can write, theta will be 2 pi of n, so final theta, no, it should be actually phi should be 2 pi by n. And what should be your angle? Your angle should be, how much your angle should be? It should be 2 phi. K, can I write it over here? The number of root, like first root, second root, and that, and it should start from, K should start from 0 to n minus n till. Okay.
So why 2 5, sir?
Yeah, let's see. Okay, I'll just put the value here and you will get the idea.
Okay.
Let's take again the example x cube. How many? What is the value of n? That is how much? 3. Okay.
3,
What will be the phi in my case? That should come out to be 120.
20.
Is that clear?
Yes.
120 should be the angle difference between, I need the angle difference between each of the root.
Yes, sir.
Okay, got it. Maybe yeah, this is fine. Okay.
But why would, like, when we're writing the roots, like, mean, when we're writing the angle, why should we 2 5 into k, sir? Why can't we write it as 5 into k?
Okay, I'll just give you the hint also. Wait a minute. You'll get the hint. Okay. Now, if I ask you from first one, what was the angle? At what angle it was?
0
From the
degree.
first 0 day, right? Put the k equals to 0. The k will have values 0, 1, and 2. Okay, it should be n minus 1, not 3. It won't go till 3 itself. Minus 1. Okay. Now it's fine. Okay. Um, it is getting erased from there. So this your 0 will go to n. No, it will go to n minus 1. Okay, that is, yeah. Now why we will putting k? You
No,
can see what happened.
sir, why are we putting 2 5 is my question, sir.
Yeah, yeah. Okay, wait a second. Look, for the second one, what should be the answer for omega? What was the angle?
It was 120, 120
The
degrees.
120 is fine. Okay, 120 is fine actually. Okay, all right. What I did is, I said just convert this into the angle between 90. You know what is the value of 120 in between 0 to 90? That is 60.
Yes, sir.
So that it should be the 2 times of 60 of k. Then it will work. Okay.
Okay, yeah, I got
If
it.
understood, if you're putting 5, you can just directly put. Okay, if you're directly putting 5, so you don't have to put 2. If you're putting the angle, whatever you will get from 0 to 90 degree, then you have to put 2. Okay, that was a correct question.
Okay, sir.
Alright, so I can just remove this 2 from here. Okay, so better, instead of doing this much long, I can directly write that whatever the angle is, it should be 2 pi k by n. Is it?
Yes, sir.
Okay, so we can directly write the theta will be 2 pi k divided by n, where n you already know that is order, and k should be 0 to n minus 1. So that's the thing. Any doubt till here?
No, sir, clear, sir.
Okay, fine. Okay, then you can remember these many factorization also, like x square plus x plus 1 can be written as x minus omega, x minus omega square. Okay, these are just some of the factorization. Basically, what is x square plus x plus 1?
It's equal to, um,
Look, basically, it is nothing but 0, right?
Yes, sir.
X plus 1. You know, this whole thing can be written as x minus a, x minus b equals to 0 it is. And a and b should be the root of it. Is it?
Yes, sir.
And what are my roots? My roots are x minus omega, x minus omega square. Clear?
Yes, sir.
So that's why we are saying this. Okay. So that's the thing. We'll move it for a while. Okay. Okay. Nth root is already what I discussed with you. All right. And in the form of Euler, if you have to write, you can write it as ei to the power. What is theta? 2 pi k by n. Clear?
Yes, sir.
Okay. Wait. Let's discuss some property. Okay. Of nth root of unity. So wait a minute. Here I can write. This chapter is going too long. Property of nth root of unity. So the first property is, if nth root of unity is there, so all the roots will be 1. Okay, the roots will be 1 plus omega square till omega n power minus. Is it? These will be the roots.
Yes, sir.
So summation of all these roots, what you are going to get? This will result you to 0 value. Is that clear?
Yes, sir.
Okay, so till this it will be clear 0. Also, if you do something like, I think it should be 2, 1 minus omega, 1 minus omega square, 1 minus omega cube, so on, 1 minus omega n power minus 1. It will result you how much? N. Okay.
Yes, sir.
So these are some of the properties. Another is, instead of this negative, you can put it as positive also. 1 plus omega, 1 plus omega square, 1 plus omega cube, and till 1 plus omega n power minus 1. It can have two values, 0 and 1. When you will be getting 0? If n is even. N is odd. Okay, this will be your answer. And the last is again same. 1 dot omega dot omega, I think it should be 2. Okay, it was 2 omega 3 dot omega 4 dot n minus. Okay, it will result you how much? Minus 1 if n is even, 1 if n is odd. Okay,
Yes, sir.
any doubt till here?
So are the derivations for this important or?
No, and derivations are not important. Like, we have too many properties. Okay, for them derivations are not that important. Look,
Okay,
for
sir.
this we have already discussed in a very, by taking a very simple example, right?
Yes, sir.
So like, if you just go through those itself, you will getting these values. Okay.
Okay, sir.
Yeah, so that's why we are not supposed to discuss too much these things about. Okay. All right. So yeah, one more thing actually we should discuss. That is, this is more important property. Cos theta plus cos times of 2 theta plus cos times of 3 theta dot dot dot. This is general property. Okay, this is not only for the these complex, if you see this kind of property, because you'll be solving problem if you see something like this, till where, till cos of n theta. Okay, this is the trigonometric property. So what will be the result of it? It will result you sine of n times of theta by 2, and theta divided by 2, divide by the whole thing. Okay, it should be divisible by sine of theta by 2. Okay, and the whole thing, whatever I have written, the whole thing should go into multiplication of cos n plus 1 by 2 of theta. Clear?
Yes, sir.
You can remember this property, because maybe you will be solving some uh, problem, and okay, you will see some this kind of pattern getting formed, so you can put it something like this.
Yes, sir.
Okay, same you will be having for the sign also, but what will be the difference if instead of this you have something like sine theta dot 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 sine and theta in the summation of, so the answer will result something like sine and theta divided by 2 whole sine theta by 2, and here instead of this cos just sine will be there. Okay, the rest part you can see is same. Clear?
Yes, sir.
Okay, so these were some of the properties. Okay, um, I had to take one more class for the complex number. It's very big chapter actually.
Okay.
After that, the quadratic equation we can cover in one class. And let's
Yes.
see. We can see like we have not even done the um, what I can say explanation of all these things. Still, the class has been taken to this. So
Yes, sir.
one more class might be there required for the this chapter. Okay. The next thing is, okay, make it, the properties is done. Okay. Next topic is there. The square root of any complex number. Okay. How you will figure out the square root of it. Let's say I'm saying get me the okay, call it as ninth thing what we're discussing, square root of z. Okay, you know that I am going to do the square root of it. So you know z equals to, let's say this is in the form of it. Okay, and I have to do square root of it, is it?
Yes, sir.
You know the answer, if it is complex, my answer I'm supposing that to be the complex, so my answer will result in the form of something like this, iy, is it? This will be, this is what my answer will look like. Okay,
Yes, sir.
so what I can do is, let's do one thing, put it like this. You know this is what my answer will be, and what it is the under root of z. So can I say it is nothing but a plus under root of this?
Yes, sir.
Let's do one thing, square both side. If you do the square of both side, what you are going to do, x square plus iy, and square is also there, equals to, if you do square this will left it like this. Clear?
Uh, Sir, I didn't.
Okay, wait, it should be square. Okay, whole of the square, not this part. Basically what we have to do, we just have to do square in the both side. Okay, then you will assume, okay, when you will be solving further you will be getting two parts, one will be real, another will be imaginary part. Okay, so from both sides we just have to compare what is the imaginary, what is the real. Understood the assignment what we have to do here?
Yes, sir.
Okay, I'll just solve further here. Okay, Look, I told this is in the form, right? What my answer should be. And it is nothing but result of this thing. What I'm doing, I'm going to do square, like squaring both sides. So you will get this as x square plus square of this will result to y square. I is there, and you know I square is nothing but minus 1, is it?
Yes, sir.
So this will become, put it negative sign here. So this will become minus, this will become negative, okay? Plus 2 times of I x y, clear? And here you will be having a plus ib. Is it clear for now?
Yes, sir.
Now what you can see, initially I had answered like my z is a and b. So can you see my a is nothing but x square minus y square,
Yes, sir.
and b is nothing but 2 times of xy. Okay, so what I have to do, I just have to figure out, like if some values are given, then only we can figure out. We have to take some relation of x and y and we have to solve it. For example, z is given as 3 plus 2y, okay? And you have to get me the root of this z. What you can do, whatever we have done so far will be still the same. You can see finally I'll be having a is equals to 3 x square minus y square, b equals to 2xy. So I can say it is nothing but 2 equals to x and y. Okay, so what my xy becomes, x and y is equals to 1. Can I say this?
Yes, sir.
You just have to take one value from here. Let's say I'm saying y equals to 1 by x. I will put here, I'll be getting something like x square minus, it is negative actually, it is minus 1 by y square is there, okay? And what is the value of y square? It will be x square.
Sir. Sir, are you saying something?
Hello, Nina. Am I
Yes.
audible?
Yes, sir. Now you're audible, sir.
Yeah, my network get off. Okay. So, okay, I explained till here. Is it clear?
Yes, sir.
Okay. So if you see what I have right now is x square minus 1 by x square to solve it out. So you can see x can be written as x to the power 4 minus 1, and here you will be having this x, you can take that side, so it will become 3x square. Okay. You can see I just have to solve another quadratic equation. How this becomes a quadratic equation? X to the power 4 minus 3x square minus 1 equals to 0. If I say my x square is nothing but k, so this equation becomes k square minus 3k minus, understood?
Yes, sir.
From here, I will get the value of this k. Let's say I got k is equals to something alpha and maybe gamma, beta, maybe two values will be there. For each of the two values, I'll be having, like you can say, this k is nothing but x square, is it? So if I'm taking, let's say k is having two values, alpha, I'll be having beta. If I say x square equals to alpha, I x square equals to beta, so I'll be having two values of alpha and beta also. Like I'll be having x equals to under root minus alpha, x equals to under root plus of under root this alpha. Is that clear?
Yes, sir.
These two values. So similarly, we'll be having x equals to under root beta minus x equals to plus of under root beta. Now you can see I had to calculate one value of b. What is y? Y is nothing but 1 by x. You can see I'll get four values of y here. Is that clear?
Yes, sir.
Now if answer says okay, these are some conditions. So you can match out the condition and you can eliminate this. If doesn't condition is there, so you can see for one root you'll be having four different values. Four different pairs will be there. Okay, one pair, second pair, three pair, fourth pair. Is that clear?
Yes, sir.
So this is how you have to calculate, okay, under root of any complex number. Any doubt till here?
No, sir. Yes, sir.
All right. So okay, this is all for the today's class actually. Okay, I have
Yes.
to take the next touch just after this.
Okay, sir.
Okay, so I'll just share you the PPT. Maybe the whole thing I'll again reshare.
Okay, sir.
Or maybe wait, from where I discussed.
So we started
This
from property 11, sir.
properties 11. So no, still I'll share the whole thing. Okay.
Okay.
Again, you can delete the previous one. Okay, and you will get the this one. Okay.
Yes, sir.
Maybe in the next class take locus of complex numbers.
Okay, sir.
Okay. Yeah, so that's all for the today's class. If you have any doubt, you can let me know, or I can just end the session.
No, sir. Clear, sir.
Oh, Simon didn't. Okay.
Yes, sir.